We're finishing off our last video in Unit 3. We're in Learning Target 3C, which is all about absolute value equations and absolute value inequalities. So in our last video, we talked about how to solve an absolute value equation, and in this video, we'll focus in on how to solve an absolute value inequality. Well, for an inequality, it really depends on what type of inequality we have. Do we have a less than, / less than or equal to, or do we have a greater than or a greater than or equal to? And those will be two different cases here. So let's look at what happens when we have a less than inequality. So to solve an inequality of the form, absolute value of x is less than a. This would also work if we had the absolute value of x less than or equal to a. The difference would just be that we would include the endpoints. We would solve that by sandwiching it into a compound inequality. So to solve both of these, we'll now be looking at compound inequalities again, which we talked about in Learning Target 3B. This is an and statement because I have one compound inequality here. So starting off with the absolute value of x less than a, I can then sandwich x in between x being less than positive a and being greater than negative a. The graph of this we've seen before would look like one continuous section where in this case I have an open circle at negative a and an open circle at a since I don't have an equals to bar, and I'm shaded in between since x is all of the values that are in between negative a and a, since I'm bigger than negative a but less than a itself. One trick to kind of help you remember this is if I write out the word less than, that L in less than kind of looks like the number 1. So when you guys think less than, I want you to think one compound inequality, which would produce an and statement for us. Let's do one example so that we can see this in action. So it says solve the following, then write your answer in interval notation, which we talked about in a prior video as well, and graph that solution set. So I have to do 3 things. I need to solve. Once it's solved, I can then write my answer in interval notation, and I will need to graph the solution set. So let's first start by solving this. So we have the absolute value of x minus 13 is less than 5. So because I have less than, this will be one compound inequality where x minus 13, or the stuff that's inside the absolute value, is going to get sandwiched in between the positive 5 and the negative 5. So the absolute value of x minus 13 less than 5 is equivalent to negative 5 greater than x minus 13 less than positive 5. So remember, we're in this less than case, so we have one compound inequality which will produce an and statement. Now we've solved compound inequalities already, so to solve this guy we know I need to move that 13, but because I have 3 pieces of it, it means I'll be adding 13 to each of these parts. So what I end up getting then is 8 less than x less than 18. And we have now solved our absolute value inequality. And that will be our answer in inequality notation. The next piece we need to do is graph it and write it in interval notation. So I'm going to draw our graph on here. Remember, we're drawing on a number line because we have one variable, and I need 8 and 18. So 8 will be on the left-hand side, 18 will be on the right side because 8 is less than 18. And I'm going to do our graph in blue. So because we have no equals to bar, we will have open circles at both 8 and 18, and then we will shade everything in between, and that will be our graph of our solution set. In interval notation now, remember that's dealing with our parentheses, our brackets, our infinities if it keeps going, or maybe negative infinities. In this case, we have one section that's bounded. We're going between 8 and 18, and on both of them we get parentheses since we have open circles, meaning I do not want to include the endpoints. So there's our first example of a less than inequality. So remember, a less than becomes an and statement where we sandwich the stuff that is inside the absolute value in between the positive and the negative number. Okay, let's look at a greater than case. So a greater than case is going to be different. And if you're thinking back to your compound inequalities, well, I already did an and, so my guess is this is probably going to be an or statement, and you are going to be correct. So to solve an inequality of the form absolute value of x is greater than a, or this will also work for absolute value of x greater than or equal to a, the way we would do this is separate it into a compound inequality that's an or statement. So one of them is pretty much exactly what we started with. It says x greater than a. The only thing I did was I dropped the absolute values. So one of these parts of the compound inequality is by dropping the absolute values and rewriting it. The second one I get by dropping the absolute values, flipping the inequality, because really I multiplied by a negative. So this other case over here, we have a negative a, and because of the negative, we have to flip that inequality sign for us. Because when we multiply or divide by a negative, we have to flip the inequality. So the absolute value of x greater than a is going to be solved by breaking it apart into x less than negative a or x greater than positive a. And one trick to help you remember this is, although greater than is spelled with an ER, well, we can kind of say it as a great or than. So we really have great or. That was kind of hard to write over it. Let me try again. So we can rewrite this as an OR. So a great or statement, to remember that we have two statements in our or inequalities. Now remember, our graph is that graph that goes out in opposite directions because we have two separate pieces. It is not possible to be less than negative a and greater than a at the same time, which is why we call it an or statement. So we have the place that goes shaded to the left of negative a and the part that is shaded to the right of positive a. Okay, let's do an example together. So it says solve the following, then write your answer in interval notation and graph the solution set. So again, quite a bit going on here. So let's start with the solving piece. So our problem says the absolute value of 8x is greater than or equal to 24. So this is going to break us apart into our compound inequality. So the first one we get is by rewriting it just without the absolute values. So this is the second case over here in yellow that I'm highlighting. So I'm actually doing that case first. It does not matter which one you do first. We can, because it is an or statement, so it's this or that. So our first case is just drop the absolute values and rewrite it. So 8x greater than or equal to 24. Or the other case comes by dropping the absolute values, and then because I'm multiplying by a negative, I have to flip the inequality. So I get 8x less than or equal to negative 24. And this is going to be our second case here. I'll highlight it in green, and that's this piece right there. Now that we've broken it apart into our compound inequality, we can go ahead and solve each of these on their own like we've done in prior sections. So to solve the first inequality statement, I need to divide through by 8. When I divide through by 8, I end up getting x is greater than or equal to 3. I do not flip the inequality because 8 is a positive number, and when we divide or multiply by a positive, I do not flip the inequality. So we get x is greater than or equal to 3, or I have to divide through by 8 again on the second inequality, and I get x is less than or equal to negative 3. Now that I have solved this, I have my answer as an inequality. We're going to want to graph this guy and then write our answer in interval notation. So to graph it, I need both 3 and negative 3 to go on the graph, but negative 3 is smaller, so I want to have negative 3 on the left-hand side, positive 3 on the right-hand side. Because we have the equals to bar, we will do a closed circle here on both negative 3 and 3. And our shading for this, I'll do them one at a time. So for the first part of x greater than or equal to 3, that means I want to shade to the right of positive 3 because I'm greater than it. For the second one that says x less than or equal to negative 3, means I want to shade to the left of negative 3 because I'm everything that is less than it. There is our graph of our solution set. The last part we need is that interval notation, and that interval notation will have two parts since I have two parts to this graph. So the piece on the left will say negative infinity, since that's the smallest, comma, -3. Remember, anytime we have an infinity, it's always a parenthesis. It's always a parenthesis with positive or negative infinity. And then on the -3, since we have a closed circle, it's going to be a bracket. Then for our second part of our interval notation, we're going from 3 all the way to positive infinity. Again, infinity always gets a parenthesis, and then at 3, because we have a closed circle, we get a bracket. And that will be our interval notation. And this question asked for all 3, so I had to make sure I solved it, drew the graph, and then wrote it in interval notation. Okay, now we've got just a bunch of examples that we're going to go through. So why don't you guys pause the video and try example 10 on your own first. Make sure you pay attention to, is it a less than or is it a greater than? And we'll check it together. Okay, let's check 10. So 10 says the absolute value of a minus 2 is less than or equal to 1. So I have a less than case, so remember that means I get one compound inequality together, so it will be an and statement. So what that translates into then is a minus 2 gets sandwiched in between +1 and -1. And because we had the equals to bar, that means the other inequality also gets the equals to bar. From here, to finish solving it, I'll need to add 2 to each part of this. So I get a still sandwiched in between, and a will be sandwiched in between 1 and +3 now. So I have 1 less than or equal to a less than or equal to +3. We've now solved our inequality. The next part I'm going to do is have us graph it. So on our graph, I need 1 and 3. I need 1 and then 3, because I want to make sure I'm going smaller to bigger. Both of these will be closed circles since I have my equals to bar. So let me fill those in all the way. And then to graph it, our solution set is what is bigger than 1 but less than 3, so it's everything in between. Remember, an and compound inequality gives me one section of it. To write this in interval notation, I want to go ahead and have 1, 3, and I'll have brackets on both parts since I have closed circles on both of those. Okay, why don't you guys pause the video and try example 11 on your own first, and then we'll check it together. Okay, let's check example 11. It says the absolute value of 3b minus 7 is greater than 28. So I now have a greater than, and I'm going to emphasize that and misspell greater than and write it as greater than. So remember, I have an or statement. So when I have an or statement, I need to break it apart into the two separate inequalities to make my compound inequality. So the first inequality will just be where we drop those absolute values. So we get 3b minus 7 is greater than 28. Or the second one comes by dropping those absolute values, and then because we multiplied 28 by a negative sign, I have to remember to flip my inequality. So I now have 3b minus 7 is less than negative 28. Now we can solve each one of these. So I'll start with the first one. We're going to add 7, so I get 3b is greater than 35. Divide through by 3, I get 3b is greater than 35 over 3. For the other statement, I'm going to add 7 and get 3b is less than negative 21. Divide through by 3 and get b is less than negative 7. You'll notice I didn't flip any inequalities as I solved because 3 is positive and I was dividing by that positive 3, so there is no need to flip any inequalities. We've solved it. Let's go ahead and graph it. Hopefully I can fit the graph all the way over here. I need -7 and 35/3 on it. So -7 definitely needs to be on the left because it's the negative number, and then 35/3 would be on the right side since it's positive. On both of these there will be open circles since I have no equals to bar. And let's take the first one. So b greater than 35/3 means I'm going to shade out to the right because I'm greater than, I want to go to the right. The second one where b is less than -7, because I'm less than -7, I want to shade to the left of -7. And this should be making sense because in an OR compound inequality, I should have kind of the two wings going out to opposite ends. To write this in interval notation, we'll have two parts of this. We'll have -infinity to -7 for the first piece. I'll have a parenthesis around -infinity because we always use parentheses on -infinity. And then on -7, I'll have a parenthesis because there's an open circle. For the second part, I'll have 35/3 off to infinity. 35/3 gets a parenthesis because there's an open circle, and then infinity always gets a parenthesis. Okay, we have two last examples left. Why don't you guys pause the video and do example 12 on your own first, and then we'll check it together. Okay, example 12 says the absolute value of 4x plus 7 is greater than or equal to 19. So again, we're in a case with a great or. Yes, I know I'm misspelling greater than, but great or, so specifically it is an or compound inequality. What that tells me then is this breaks apart into 4x plus 7 is greater than or equal to 19. So the first one, just drop those absolute values. Or in the second one, we drop the absolute values. And then because we multiplied 19 by a negative, we have to flip the inequality sign. So we get 4x plus 7 is greater than or equal to 19, or 4x plus 7 is less than or equal to -19. We can now go ahead and solve each of those inequalities. So for our first one, we get 4x is greater than or equal to 12, divide through by 4, and we get x is greater than or equal to 3. Or in our second one, when we subtract 7, we get 4x is less than or equal to -26. So x is going to be less than or equal to -26 over 4, which we can reduce that down since both 26 and 4 are divisible by 2, and get x is less than or equal to -13/2. So our final answer here, let me try to box the whole thing, is those two inequalities. X is greater than or equal to 3, or x is less than or equal to -13/2. We're not quite done yet because we're asked to graph this guy. So on a graph, we have -13/2 and then 3, making sure we go smaller to bigger. On both of these, we will have closed circles since there's an equals to bar on both of them. And remember, because I started with an equals to bar at the beginning of the problem, that's why both of the compound inequalities had an equals to bar. In terms of shading, let's take this one piece at a time. So for x greater than or equal to 3, it means I want to shade to the right of 3 because I'm greater than it, bigger than it, so to the right. For x less than or equal to -13/2, I want to shade to the left because I'm less than, so I'm the smaller values. Then for our interval notation, we'll have -infinity to -13/2 for the first part. I'll have a parenthesis around -infinity because we always put a parenthesis with our infinities. Then I'll have a bracket on -13/2 because of the closed circle. Then for the second piece, we're going 3 off to infinity. I'll have a bracket on 3 because of the closed circle, and a parenthesis on infinity because we always use parentheses on that guy. Okay, we've made it down to our last example of Unit 3. Why don't you guys pause the video and do 13 on your own first, then we'll check it together. Okay, example 13 says the absolute value of 3x minus 2 is less than or equal to 12. So I have that less than, so remember that's our 1, because our L kind of looks like a 1. So I have an and statement here. So I'm going to need to sandwich my 3x minus 2 in between 12 and negative 12. And again, because there was that equals 2 bar, that's why they both have an equals 2 bar. We can go ahead and solve this guy. I'm going to start by adding 2 to each piece. So we get negative 10 less than or equal to 3x less than or equal to 14. From here, I can divide through by 3, and we get negative 10 thirds less than or equal to x less than or equal to 14 thirds. Now, neither of those fractions can be reduced down any further, so we have now solved our inequality. When we go to graph this guy, I have my negative 10 thirds on the left, 14 thirds on the right, because I have to go smaller to bigger. Both of them are closed circles because of the equals 2 bar. And then for the shading, the solution set is saying that I'm bigger than negative 10 thirds, so I should be to the right of negative 10 thirds, but I'm less than 14 thirds at the same time, so I'm everything in between those two numbers, which is why x is sandwiched in between those two numbers. Our last thing we have is our interval notation, so I have negative 10 thirds to 14 thirds. Because there's only one piece that's shaded on our graph, then there's only one interval notation. That 10 looks a little messy. Let me fix that for us. They will both have a bracket since I have closed circles on both negative 10 thirds and 14 thirds. And that is our last example with absolute value inequalities, which also takes us to the end of Unit 3.